Okay, we're in section 4-4 of the differential equation book. And we're dealing with, first of all, we're going to deal with convolution of two functions. So if I'm going to convolute f with g, then I'm going to take the integral 0 to t of f of tau g of t minus tau d tau. And I'm going to be very careful and keep my variables straight so I don't mess them up. And we find that the convolution of f of g turns out to be the same as g of f. And maybe you've seen those functions before, maybe you haven't. Now, that doesn't seem to do much for us, but if I were to take the Laplace transform of the convolution of f of t, g of t, that's going to be the Laplace transform of f of t times the Laplace transform of g of t. Boy, that was good. Wasn't that great? So I could go the inverse Laplace transform, and it's just another way to write it, of f of s times g of s will be equal to the convolution of f of g of t. And then in order to solve for this, we'd have to do the integral thingy. All right, so that's convolution property. And then we're going to deal with Theorem 2, which has to do with the differentiation of a Laplace transform. So if I take the derivative of the Laplace transform, that's the same as taking the Laplace transform of minus t f of t. And, well, that doesn't do much for us. So f of t will be the inverse Laplace transform of f of s, which will be minus 1 over t, inverse Laplace transform of f of s prime. So if we have an f of s that we can't find the Laplace transform of easily, but we can take its derivative and get something that is easy to find it, then getting the reverse Laplace transform should be pretty simple. So that's what that gives. All right, and then if we're not differentiating Laplace transforms, we're integrating Laplace transforms. So Theorem 3 says if I have the Laplace transform of f of t over t, that's going to equal the integral 0 s to infinity of f of sigma g sigma. So I could rewrite that and say that f of t could be inverse Laplace transform of f of s, could be t reverse Laplace transform of the integral s to infinity f of g of sigma d sigma. Okay, well that's the theory involved. Now it's a matter of, can we actually work a problem? So we'll look at number 2. Now I'm not open to the syllabus, so I don't know what problem sets we're supposed to be doing. So that'd probably be a worthwhile thing to look at. Okay, so now I am. Section 4, 1 through 1 through 34 odd. Okay, so I'm going to do number 2. So f of t is t, and g of t is e to the at, and we want to find f of t convoluted with g of t. All right, so we don't do that without it being open to the right page of the book, and we're going to say that that's going to be equal integral 0 to t of f of tau, which would be tau, g of tau, which would be e to the a t minus tau d tau. Okay, what would that be? I guess I'd have to do integration by parts, wouldn't I? Oh, wait a minute. Maybe I can just go look in the back of the book and it would tell me what that integral is. Wouldn't that be convenient? And all it's telling me to do there is just do integration by parts. So number 47 in the back of the book. Okay, so I'd probably say this is e to the at, because e to the at is just a constant. Integral 0 to t of tau e to the minus a tau d tau. And then I remember, well, I just used the back of the book. And number 47, so it's going to be e to the at times tau e to the a minus a tau can't do that. All right, back to the drawing board. The derivative of uv, u prime v plus v prime u. V prime u is duv minus u prime v. Integrate, integrate, integrate. So the integral of v prime u is uv minus integral u prime v. So that's integration by parts. So I'm going to let u be tau, and u prime is going to be 1, and that leaves v prime is going to be e to the minus a tau, and v is going to be minus e to the minus a tau over a. Okay, so I'm going to have e to the at times u, which is tau, v, which is minus e to the minus a tau over a, evaluated at 0 and t, minus integral 0 to t of, he's 1, and this guy is going to be minus e to the minus a tau over a d tau. All right, so I'm going to have e to the at. I put a t in for tau, and I got t minus t e to the minus a t over a. I put in a 0, and I'm going to get plus 0. All right, minus, now I'm working on this interval, and the minus becomes a minus, and I get a plus. Okay, that's fine. And I get minus a minus e to the minus a tau over a squared, evaluated at 0 and t. And then I got e to the at minus t e to the minus at over a plus, I put in a t, and that's a tau sitting there, so I better keep it tau. I'm going to put in a t, and I get minus e to the minus at over a squared minus, I put a 0 over there, 1 over minus 1 over a squared. And I'll throw in another bracket. So we're going to get minus t over a minus 1 over a squared plus e to the at over a squared. Now, we're not going to bother to look in the back of the book or anything to see if it's right. We're just, because if it's wrong, we're so hosed, it's pathetic. So.
How come on the first part of the derivative, how come you have a t that, isn't it just uv? There's no integral in the first part.
Yes, there is. When I take the integral of the whole thing, it's not just uv sitting here. It's uv evaluated at the limits of that integral. Because this was 0 to t sitting on that interval when I took the interval. Yes.
Okay.
Yeah. So that's implied in the integration by parts formula. Yeah. You knew that, right? Yeah. Yeah, you knew that. Yeah. All right, so that was... Scroll back down. How about changing colors as I go next time so it's more clearer? I wonder if I can remember what that was. Minus e to the minus a tau over a squared. Okay, is that better? Should I do another one, or did I embarrass myself enough on the front? I guess I should go look in the back of the book. All right, you convinced me. Section 5, nope. Section 5, Section 5. Four. Oh, look at that. E to the at over a squared and a minus t over a and a minus, yep, checks with back of book. Darn. I was so hoping I'd missed the first one. Then we could go home, because if I can't do one of them, I can't do any, right? Okay, well, we got that one right. Now we got to get back to the problem set. And I think we'll do number 8 next. Number 8. Now, if I was going to do number 8, 1 over s squared plus 4, right? I would do it with partial fractions. But we are in section 4.4, and it tells us we have to do this using convolution. Okay, so what did convolution say about this particular thing? It said if I took the inverse Laplace transform of 1 over s times 1 over s squared plus 4, then that's the same as taking f of t convoluted with g of t. Now the issue is, what is f of t? Well, if 1 over s is capital F of s, then f of t has to equal 1. And if this is capital G of s, then g of t has to equal 1/2 sine 2t. Okay, so that's from number 8 on our table and number 4 on our table. So now I know what that convolution is. So now the convolution is integral 0 to t of 1 times 1/2 sine 2 tau d tau. And no, it's not. We're just hoping it was that. 2t minus tau d tau. All right, so that's what the convolution is from page 297. Okay, so that's what we have to do. All right, well, that'd be minus the cosine of 2t tau minus tau. Or is it positive? I think it's positive. Value between 0 and t. 1/4? 1/4. Okay. So if I take the derivative of this, the 2 goes out in front, it becomes a 1/2. I have a sign, and it's a minus sign, right? And then I take the derivative of that, and I get a -1, making it positive. So it looks like that's right. So this is going to be, I put a t in there. T minus t is 0. Cosine of 0 is 1. So that'd be 1/4 minus, I put a 0 in for the tau, 1/4 cosine 2t. Now, why is it that I don't think that's right? I don't know. Number 8. Nope, 1/4 minus 1/4 cosine 2t. That's correct. So that makes 2 in a row correct.
Can you do a loan before you turn the page?
For a convolution. Again, if I was really going to do that, I would do it with partial fractions, but because I'm in this section of the book, I don't have much of a choice. Okay. So what's our pleasure? Number 12 or number 14? How about both? We'll do number 12 and number 14. Well, we'll do number 12 anyway. So I've got 1 over s times 1 over s plus 2 squared plus 1. Okay, that's what I have. So this guy's here f of s, and this guy's here is g of s. And if I take the inverse Laplace transform of that, that's the same as taking f of t convoluted with g of t. Okay, so this is going to be 1 again, so that's pretty simple. And then convoluted with s plus minus 2 squared plus 1. So that's going to be number 9. Look at number 9. And that's going to be e to the at, which would be minus 2t sine t. Okay, so that's what that would be. And then that would be integral 0 to t of e to the minus 2 t minus tau sine t minus tau d tau. Yeah, that may or may not going to happen tonight. Let's see what the back of the book says. Yeah, I don't see why not. Is there any reason why we can't do that? That looks like number 49. Right. So this is number 49 integral from the back of the book. We just have to go and change it ever so slightly. Or change it a whole heck of a lot. So we have integral 0 to t, e to the minus 2t, e to the 2 tau. what's this difference of the sine function? Anybody remember the difference of the sine thing? Do I have to go run to my office and get my tech math book? Okay, Maple, come to our aid. What's the formula for the difference of the sine? Yeah, this is where you have to remember your trig. So, but all right. So I'm going to have the sine of A minus B. Thank you very much. Expand. Just love, don't you just love Maple? There we go. I knew that. Sine, cosine, minus cosine, sine. All right, so this is sine t cosine tau minus cosine t sine tau d tau. All right, so this is I can bring out e to the minus 2t sine t, because that's just a constant. Integral 0 to t e to the 2 tau cosine tau minus e to the minus 2t cosine t e to the 0 to the t e to the 2 tau sine tau d tau. Is that what you're thinking of doing? And now those are just right out of the back of my book now. That's number 49 and 50 out of the back of my book. So this guy's number 49 and this guy's number 50. And so we're going to have e to the minus 2t sine t times. Okay, so that's number 50. So that's e to the minus 2t. No, it isn't. That's e to the 2 tau. E to the 2 tau divided by a squared, which is 4, plus b squared, which is 1, times a, which is 2, cosine b, which is 1, plus b, which is 1, sine 2, no, that's b, which is still 1. B is still 1. Tau, evaluated at 0 and tau, minus e to the minus 2t cosine t. And now we're looking at number 49 in my integration table. E to the 2 tau divided by 4 plus 1, which is going to be 5 again, times 2 sine t times sine tau plus 2, no, minus, minus 1 cosine tau evaluated at 0 and t. Okay, what could be more simpler than this? Okay, so I've got eating a Girl Scout cookie could be simpler than this. There's one example. Okay, I put a t in, so I get e to the 2t over 5, 2 cosine t plus sine t, minus, I put a 0 in, and I get a 1/5, and I put a 0 in, this becomes 0, that becomes 2. Okay, Okay, so that's that guy. Minus e to the minus 2t cosine t times e to the 2t over 5. Okay, I'm putting a t in. I just did that. Times 2 sine t minus cosine t minus, I put in a 0, I get a 1/5, and I get a minus 1. Okay. So now I got e to the 2t, e to the minus 2t, they both go away. So I've got sine t over 5, 2 cosine t plus sine t minus 2/5 minus 2. No, couldn't be that easy. All right, there. If I do that, then it'll be better. Minus 2/5 e to the minus 2t sine t minus, on the bottom, okay, I've got minus, this guy goes away, 2 cosine t sine t over 5 minus plus, minus and minus makes a plus, cosine squared t over 5. Okay, and minus, minus, minus makes a minus. Minus 1/5 e to the minus 2t cosine t. Well, what do we got here? I've got sine squared plus cosine squared is a 1, right? So, and I got 2 sine cosine minus 2 sine cosine. So this term goes away with that term. This term and that term with this term becomes a 1. So that becomes a 1/5. So that guy and that guy goes away. And now I got 1/5 minus 2 over 5 e to the minus 2t sine t minus 1/5 e to the minus 2t cosine t. Anybody remember what problem we're working? 12. And 4, 4, 12. 1/5 minus 1/5 e to the minus 2t sine cosine t minus the other guy. Yep. Oh, wow. 3 in a row in section 4.4. This is amazing. I don't think I've ever had 3 in a row in this section in my entire life. I don't think it's possible to have 3 in a row. Huh? You never will have 3 in a row? Yeah. Well, should we do 14? All right. 3 in a row. Oh, well. Okay, we'll start number 14, knowing that there's absolutely no way we can get it right. Would that be okay? So f of s over s to the 4th, 5s squared plus 4. Okay, so we have s divided by s squared plus 4 times s squared plus 1.
There's supposed to be a 5 in front of the squared.
Well, you can read the book. What do you think? You want me to look at the book for you? Is that the issue? I don't understand. All right, so you want me to make this look like a better 5. Some people, in case anybody was wondering, that was Andrew that asked that question. So I got s over s squared plus 4 times 1 over s squared plus 1. Okay, and that would be a cool thing to do, because if I put the s over the other guy, then I'd need a 2 up here when I do my Laplace transform. So this is going to be, this guy's f of s, this times g of s, and so f of t is going to be cosine 2t, and g of t is going to be sine t. Is that not so? Where's my Laplace transform table? I hit it someplace. Yeah, cosine 2t, and yeah, 8 and 10. That's by 8 and 10, number 10, number 8 of our Laplace transform table. And so the inverse Laplace transform of that guy is the convolution of this guy. All right, so we want to find the integral 0 to t cosine 2t sine t minus tau. That's a silly way to make a minus sign. D tau. Okay, so I'm going to go integral 0 to t cosine 2t, and then I recognize t minus that being the same sign guy, so I'm going to have sine cosine minus cosine sine. Okay, so that'd be sine t cosine tau minus cosine t sine tau d tau. Okay, that shouldn't be too bad. That should be, so this is going to be cosine 2t is just a constant. So I go 0 to tau. And, well, okay, well, that'd be good. Sine t. What happened to my 2? Oh, right, there is no 2. Oh, good. Look at that. There's no 2. Isn't that great? I picked the right one. Okay, so that'd be sine cosine tau minus cosine t sine tau d tau. All right, so I got cosine 2t times the integral of cosine is going to be sine, right? So it's going to be sine squared. No, it's not. It's not going to be sine squared. It's just sine t sine tau minus the integral of sine is minus cosine, so that's going to be plus cosine t cosine tau evaluated at 0 and t. Okay, so that's going to be cosine 2t times, I'm going to put in a t in, and that's going to be sine squared plus cosine squared, so that's going to be a 1, minus, I put in the 0, and that goes away, this becomes a 1, minus cosine t. And that should be our final answer. And we're looking at number 14, and we have 1/3. Do I have a 1/3 anywhere? No. Are we doing 14? I don't remember.
Yeah.
We are doing 14?
Oh, it's supposed to be.
Oh, 14. What a bummer. It says that it's supposed to be 1/3 cosine t minus cosine 2t. Okay, well, I knew we were in trouble. Okay, did I factor that right? I factored that right? Yeah, I factored that right. So now the issue is this the same as the answer in the book? And all right, well, why don't we do something weird? We're going to go and ask Maple, we're going to say that there is absolutely no way we can make an error in that problem, right? Well, there's several ways, but we're going to say that. And we're going to go inverse Laplace, well, search, inverse Laplace transform. Because we know that Maple, oh, way to go. What did I do? What did I misspell? Okay, so there's the Laplace transform. Why can't I have inverse? Inverse, V-E-R-S-E. Is that the way I spelled it the first time? Way to go, table of content. There we go. Laplace transform we already saw that. Laplace equation, Laplacian. Am I misspelling inverse? I-N-V-E-R-S-E? Am I misspelling Laplace? Well, I know that you guys do inverse Laplace transforms. I know you do. So now the issue is, where the heck are you? Laplace transform inverse. Boy, it is being stubborn, isn't it? Well, you spell inverse with an I, right? Inverse, tangent, inverse, I don't believe it. There's no inverse Laplace transform. Laplace transforms and inverses. There we go. There we go. Okay. We'll copy that. Copy. Paste. Okay. Interesting. That's the one we want. That's the inverse. So that's the inverse Laplace transform. Okay, that's better. Calculate the Laplace transform inverse. Okay, so there. So here, that's the same thing I had before. What am I doing? Anybody paying attention out there? It says inverse right there, doesn't it? Yes, it does. Copy. Why can't that be pasted? Inverse. There we go. So now all I have to do is put up here what my equation is. Okay. So I've got S divided by S raised to the fourth plus 5 times S squared plus 4. Okay. And down here we'll put in a $sign, meaning we want to use the equation above. No, pound, yeah, percent sign. Boom, right. Got the right thing. Cosine A, cosine B minus cosine A, sine B, the drachia of t. Anybody know what the drachia of t is? Now we got to go find, oh, expand. Thank you very much, Mabel. That is just so much help. But you notice what it doesn't say. It doesn't say that it's 1/3 cosine minus 1/3 cosine 2, right? So I think that the answer in the back of the book is not right, but it's hard to say. Okay, so this will be a question mark. Do we have it right or not? Yeah.
You should go up a little bit.
Why? Did you see where I made the error?
No. Go for more. All right. How did you do the integral of that? Just 'cause I don't know, it's kind of weird.
This integral?
Yeah, it's like walk.
Okay, well, all right, so first of all, we have to agree that that's the integral we want. And if that's the truth, then the cosine of 2t in relationship to d tau, d is a constant, right? So now it's just a matter of what is sine t minus tau. And so I brought the constant out, and I expanded the times t minus tau. And then I went and sine t is just a constant. So that's right, it's just a constant in relationship to tau. So the cosine tau becomes a sine. The sine tau becomes a cosine. When I put in a t, it becomes sine squared plus cosine squared, which is a 1, minus, when I put in a 0, that term goes away. This term becomes minus, put in a 0. Minus t. Yeah, so that's why I like my answer. My answer looks real good. Where?
In that integral from 0 to t?
0 to t, right.
Cosine 2 tau?
No, because g of t is where the tau minus t minus tau is. So if you look in the so you look on page 297, and we're going, oh, you're right. You're right. Darn. Okay, so that's where the problem is. Okay. So we're going to erase everything from here down because that's not a constant. Okay, because this is 2 tau, not 2t. You're absolutely right. Okay, well, now that we found the mistake, it'll probably be very easy to get the right answer this time. I knew I did something wrong. That was much too easy to have it be right. Okay, so I got integral 0 to t of cosine 2 tau times sine t cosine tau minus cosine t sine tau d tau. Okay, now I've got integral 0 to t of sine t cosine 2 tau cosine tau minus cosine t cosine 2 tau sine tau d tau. Well, I guess that is very interesting. All right, so we'll go to Maple, and we'll ask Maple, what is the cosine of 2t times the cosine of t? And we'll expand that. Way to go.
Give an L in there. Bracket P.
5? No. Shit. Still 5. All right. Boom. Boom. Oh, really? It's cosine 2 cosine t cubed minus cosine t. All right, so this is integral 0 to t of sine t times 2 cosine cubed 2 cosine cubed t, and that's a tau. Yeah. That's a tau, and minus cosine tau. Minus cosine tau minus. All right, now we want cosine 2t sine t. I don't think we're going to get that, though, even though we want it. Cosine t. Okay, so we want cosine 2t cosine 2t sine t sine t. Okay, so this is going to be 2 sine cosine squared 2 sine cosine squared 2 sine cosine squared minus sine. And that's a tau, that's a tau, that's a tau, d tau. Okay, so I can do this integral, I can do that integral, I have no idea how I'm going to do that integral, but I can do this integral. So the only integral I'm worried about is sine. Wait a minute, I can do that integral too. Okay, so now I'm all set. I can do all those integrals. So I've got integral 0 to t of sine t 2 cosine cubed tau minus integral 0 to t sine t cosine tau minus integral 0 to t cosine t 2 sine tau cosine squared tau minus plus integral 0 to t cosine t sine tau. Okay, so that's all there is. There ain't no more. All right, well, this is going to be 4 1/2. So this is going to be 1/2 sine, 1/2 cosine, 1/2 cosine to the 4th tau. And the derivative of cosine is minus sine, so I'm going to have to have minus sine there, 0 to t. No, this is cosine. If I take the derivative of this, I get the 4 goes out there, and I get 2 cosine cubed, and then I take the derivative of the cosine, and I get minus sine, and the minus sign goes there with a minus sign.
That sign's a T, no.
Oh, shit. Yeah. Now I'm relying on Maple again to go back and get the, now let's see if that integral, you're right, I don't have that integral. I thought I had that integral, but I don't have that integral. So I need the integral of the cube of cosine, and that's
Number 33 has it.
yeah, number 33 has it. All right, so that should be relatively simple.
Would be 1/3.
So that's where the 1/3 comes from?
I think so, yeah.
All right, so this is 1/3 cosine squared tau sine tau plus 2/3 integral cosine tau d tau, the whole thing's times 2 the sine of t. All right. Well, that was pretty simple. And now this guy, I can do that integral. That's an easy integral. This okay. So anyway, we have more things to do. So we'll go and doing those. We'll start doing those more things. So this is solvable. And but I do have a 1/3 sitting there. That's very encouraging. All right. Now we're going to move to number 16. Oh, I don't want to do 16. We're going to do 18. 18. All right, so f of t is equal to t e to the minus t sine squared t. And we were trying to find the Laplace transform. Okay, so maybe I don't want to do that one either. Number 18, apply either theorem 2 or 3. Okay, so I'm going to apply theorem 3. And I'm going to say f of t over t is equal to e to the minus t sine squared t. Okay. F of t over t is e to the minus t sine squared t. I don't see how that's going to work.
Can you break it down and just do
Yeah.
the Laplace of sine squared?
What? Who?
Can
What?
we just do the Laplace of sine squared and then do it in parts?
No, we're trying to do theorem 2 or 3. No, I don't see that either. All right, we'll do number 20 then, because it looks like I can see number 20. Number 20. F of t is equal to 1 minus cosine 2t over t. T, f of t, is equal to minus 1 cosine 2t. Okay. I need a minus sign here, and I need a minus sign there and a plus sign there. If I take the Laplace transform of this side, then the answer is going to be f prime of s. Okay. So if I take the Laplace transform of this side, I'm going to get minus 1 over s plus s over s squared plus 4 is going to be the derivative of f of s. Okay, so now I'm going to have to take the integral of both of them to find f of s. Natural log s plus 1/2 natural log s squared plus 4. What do you think? Huh? What? No. Yes. No, yes, no, yes, no, yes. Yes. All right, so this is number who? Number 20. 1/2 natural log s squared plus 4 minus natural log s. And I would have had it wrong, but Andrew saved me and told me to put the minus sign there. Okay. All right, so that means that we got number 20 right. All right. Now, what problem were we trying to do before we did that? 18. All right, so we're going to go back to 18. And f of t is equal to t e to minus 1 sine 2t. F over t divided by t is equal to e to the minus 1, e to the minus t, e to the minus t sine 2t. No, sine squared t. Sine squared t. Do we have a Laplace transform for sine squared? No, we don't. I put a minus sign here, I put a minus sign there. I take the Laplace transform of this thing and the Laplace transform of that thing.
And you take one of the signs away, like sine times sine, like distribute it out and use number 9. Look at number 9 and do a plot.
Number 9. No. I'd have to use convolution on it to get it. And that would not be good. No, I don't see any easy way to get this one, so we'll skip on by it. I thought I was going to have that one too. Okay, we'll look at 24. 24. F of s is natural log s squared plus 1 over s squared plus 4. Okay, and then we'll say f of s is equal to natural log s squared plus 1 minus the natural log of s squared plus 4. Then we'll take the derivative of both sides and say f prime of s is equal to s over s squared plus 4 plus 1. 2s over s squared plus 1 minus 2s over s squared plus 4. Okay, and then f prime of s is equal to, this is equal to the Laplace transform of minus t f of t is what f prime of s is. Okay, so if I take the inverse Laplace transform of this whole thing, thinking of that stuff there, right? I'm going to have minus t, f of t. I'm going to have 2 cosine t minus what? Minus 2 cosine 2t. So I'm going to have f of t equals 2 cosine 2t over t minus 2 cosine t over t. That's number 24. 24. 2 cosine 2t over t minus cosine t 2 cosine. Okay, yeah, same problem. All right, correct. Boom. All right. What's that? We're on a roll. We got one right. Ooh, 26. 26. F of s equals the arctangent of 3 over s plus 2. Really. Gotta. Anyway, f prime of s, because we're in this section, we're going to take the derivative of that guy. All right, so what's the derivative of the arctangent? The derivative of the arctangent. Hmm. 52?
Number 52 was from the very bottom.
52. That's the integral of the arctangent. How does that help me? Huh? That doesn't help me. That's no help at all. I want the... Now, if I had my TechMath 2 book, it would tell me. All right, so. Yeah. Okay, so we want the derivative of the arctangent of 3 over x plus 2 of 3 over x plus 2. I knew that. Didn't you know that? I don't see where that's going to be helpful, but 3 over s plus 2, the derivative of the arctangent. Okay, so that's going to be 3 over s plus 2 squared times 1 plus 1 really times 1 times 1 plus 9 over x plus 2 squared. s squared. Okay, well, obviously they weren't thinking of doing an inverse Laplace transform on this, right? So I've got 3 over s plus 2 squared plus 9. Oh,
There's a negative in front of that. The whole thing itself.
no, not yet, is there?
Yeah, there is.
Oh, right there. You mean that negative there? All right, negative. Okay. So this is something simple. Okay, so now I look in, where is that thing anyway, derivative? So the Laplace transform of minus t f of t is going to equal minus 3 over s plus 2 squared plus 3 squared, right? Now, this negative and that negative can go away. And I'm going to have f of t equals, and where is my Laplace transform? That is number 9. Number 9 on the Laplace transform table. So it's going to be e to the minus 2t sine 3t divided by t. And that was problem number 26. And 26, e to the minus 2c sine 3t, blah, blah, blah. Check. All right, so other than the minor inconvenience of having to find the derivative of the arc tangent, which we were unable to do because we forgot what it was, we know what it is, right? It's the derivative of the arc tangent. It would be 1 over u squared plus 1 over u squared, probably something like that. Yeah. But anyway, if I had my tech math book, I'd know what it was. Yeah. All right, well, we got 26 right. That's all that matters. Okay, we're going to do number 30 next, and then we're going to go home. What do you think about that? Number 30. Okay, so I've got t x double prime plus 3t